Hello students, welcome to E-Pathshala. I am PG Padma Gauri, working as an assistant professor in Faculty of Engineering, Avinash Lingam University. Today we are going to discuss the module Heat Transfer and HVAC in Interiors. HVAC is applied in the individual buildings or other enclosed spaces. The equipments involved in some cases an extension of a larger distant heating or distant cooling network or a combined direct heating and cooling network. In HVAC equipments, the operating and maintenance aspects are simplified and metering becomes necessary to bill for the electrical energy that is consumed. In some buildings, HVAC equipments releases the energy that is reused for other system. For example, at a given time, the building may be utilized cold water for air conditioning and the warm water is returns may be used in another place in building for heating or for the overall heating portion of the direct heating and cooling network. Objectives: to understand the concepts of heat transfer in the buildings, to know various ventilation systems used in construction of buildings, understand and apply air condition systems in buildings. Heat is one form of energy. Heat as molecular energy and universally accepted. Since all the forms are converted into heat, it is considered to be energy in its lowest form. Availability of heat energy to do work depends on a temperature differential. Temperature is a property of matter and it is the measure of intensity of heat or that heat level, and it has a relative value. A substance is said to be hot or cold when temperature is compared to some other reference temperature. Heat is not visible like other forms of energy. Heat can be measured because it have quantity and intensity. In building indoor, the ambient temperature is called as room temperature. The outside surrounding air or the weather ambient temperature refers to the current air temperature or outside temperature. Heat transfer: if there is a temperature difference between the conditioned indoor space of a building and outdoor, ambient heat transfer takes place through the building structure like walls, roof, floor, etc. This phenomenon is known as heat gain or loss of the building's interior. In heat gain in the interior is nothing but heat transfer is from surrounding air to the building. In heat loss in the interior is nothing but heat transfer is from building to the surrounding air. The heat transfer includes sensible heat transfer through all the structural elements of a building. The commonly known modes of heat flow are conduction, convection and radiation. Conduction in solids, convection of fluids like liquids and gas, radiation through anything that will allow radiation to pass through it. Every material used for construction of buildings have a property of low conduction or high conduction. Conduction is heat flow on a molecular scale, medium at rest or moving. Convection is heat conveyed as internal thermal energy of mass that is displayed by mean or turbulent motion. Radiation is heat transfer by electromagnetic waves such as infrared or visible light. Requirements for producing comfort: since heating of buildings is normally required to provide comfort for the occupants. Under normal condition, the average human body dissipates between 100 to 200 watts per hour and has a surface temperature of about 27 degrees centigrade. Of the above quantity of heat, about 40% is dissipated by radiation, about 30% dissipated by convection, and the remainder 25% by evaporation. The radiation is covered by the temperature of the surrounding walls and other objects, the convection by the air temperature, and the evaporation by the humidity of the air. For the comfort of human, the temperature of indoor maintained desired level. However, circumstances in which considerable variations from the above can be allowed without causing discomfort. Maintaining correctly temperature and humidity, various technological and decorative aspects are taken into account. We design a heating techniques is to aim at maintaining an inside temperature between 17.2 degrees centigrade and 18.3 degrees centigrade. If it is not desirable, however, to maintain more than 8.3 degrees centigrade to 11.0 degree centigrade difference between indoor and outdoor temperatures. Different types of heating system. Numerous types of electric heating equipments have been developed, and those which have found application in practice may be classified as follows: high temperature radiators, low temperature converters, panel heating, air conditioner, thermal storage. Heating system. In northern part of India and foreign countries, the temperature in winter goes below freezing temperature of water. It becomes necessary to heat the houses by supplying the heat from external sources to maintain the comfort condition for the people. Heating systems are required for low temperature places like North India. Proper control of temperature and humidity provides comfort to the human bodies. To maintain the rooms of the building at the comfortable temperature, it is necessary to supply continuously a definite amount of heat to each room equal to the amount of heat lost by the room to the surrounding atmosphere. There are different types of heating systems. All require certain essential elements as given in below: a fluid for conveying heat, a compression chamber where a fuel is burned and the heat is given to the fluid used in circulation, arrangements of pipe for conveying the hot fluid to the hot rooms. The radiators are convectors for dissipating the heat into the rooms. Classification of heating system. Warm air furnace system. Systems providing circulation through pipes. Pipeless systems. Fan and furnace system. Hot water heating. Forced circulation system. Natural circulation system. Steam heating system. High pressure system. Vapor system. Vacuum system. Warm air furnace system. Warm air furnace heating is used natural circulation. The air is heated in the furnace, becomes lighter and rises through the ducts to the room. The part of air supplied to the room is mixed with the fresh air. The hot air is usually supplied at the floor level. The circulation of the air from floor level to ceiling level is done by proper circulation method. Advantages of warm air circulation furnace system. The capital cost is usually lower than water heating or steam heating system. Simple in operation. Low running and maintenance cost. Adjustable room temperature. Noiseless air circulation. Disadvantages of warm air furnace system. It cannot be used for big buildings, factories and multi-storage buildings. Equal air distribution through the room is not possible. Proper control of humidity not possible. Hot water heating. Hot water is very popular heating medium for central plants. The flow of water in the plant may be produced as a result of density differences between hot and cold water, or it can be pumped by putting pump in the system. The expansion tank is placed at highest point of the system. In the case of the fire becomes hot and causes the water to boil, then the steam will escape through the open top of the expansion tank. The gravity flow circulation arrangement is converted into forced circulation by addition of pump into the circuit. The temperature of the water supplied to each radiator is lower in size. Steam heating system. Latent heat. Latent heat is the heat energy which is in hidden form and has to be supplied to change the state of a surface without changing its temperature. That is, solid substance melting particular temperature is called latent heat. Steam heating systems are preferable to the other systems of heating because it carries more quickly of heat per kg of steam compared with per kg of water or air. The useful heating is caused mostly by condensation of steam when it is supplied to radiators and convectors. The quantity of heat given by condensation of steam at atmospheric pressure is equivalent to the value of latent heat of vaporization, which is 540 kilocalorie per kg of steam. The latent heat loss was eliminated by using steam heating system. Pressure value also increased. It results less diameters of steam pipe only required. High pressure stream supplied to the dissipators more quantity of heat per meter squared area of the radiator and requires small diameter pipes. The radiators capable of heating the building satisfactory in sub-zero temperature would overheat the buildings in the mid-weather condition. Classification of electric heating equipments. High temperature radiators. The domestic electric radiators are fire consisting of a resistant element operating at a red heat is called high temperature radiators. Low temperature converters. It is a open heat closed resistance element operating at 66 degree or 93 degrees centigrade. It is designed and located to produce convection currents. Panel heating. Large panels of fire clay or other suitable substance in which is incorporated resistance wire. Such panels are mounted on or built into the walls or ceiling and dissipate their heat by radiation. Air conditioning. The air circulated through the building by the ventilating equipments is free heated and also, if desired, treated for control of humidity. Thermal storage. Hot water is circulated through pipes and radiators, the water being heated electrically. The salient features of these systems are the sufficient heat can be stored in the water to allow the current to be switched for several hours. The classification of steam heating systems are: 1 pipe gravity return system, 2 pipe gravity return system, vapor type gravity return system, vacuum system with vacuum pump. Ventilation system. Ventilation. Ventilation is the movement of air into and out of an interior space by either natural way or mechanical force. Natural ventilation system. The flow of air caused naturally, thus the pressure difference between the ambient air and the air in an closed space is known as natural ventilation system. The flows of air caused due to this known as wind, as wind blows is always uncertain both in its direction and speed. So, there is no control of dust and odor carried by incoming air. The natural ventilation system has no significance in air conditioning plants. Mechanical ventilation system. The control ventilation caused with the use of fan is known as mechanical ventilation system. This is essential when the temperature, humidity and air motion are to be controlled in an air conditioned space. Extraction system. This is most widely used method in air conditioning plant. The air from the air conditioned space is withdrawn by the action of suction with the help of suction fan. This is accomplished either by using the propeller fan exhausting through holes in the wall or by means of duct depending upon the requirements. To ensure the uniform fresh air can be combined with extraction system, it is called as complaining system. Air conditioning system. Air conditioning system defined as an assembly of different parts of the system used to produce a specified condition of air within required space of the building. To select proper air conditioning system for a given space requirements is difficult task. The designer has to keep in mind the fitness of the system to the space to be conditioned and the classification of the customers. Selection of air conditioning system, economic conditions also plays an important role. Ideal air conditioning system should maintain correct temperature, humidity, air purity, air movement and noise level. Classification of air conditioning system. Central station air conditioning system, unitary air conditioning system, remote air conditioning system, direct air conditioning system, self-contained air conditioning system. Central station air conditioning system. In central station air conditioning system, all the components of the system grouped together in one central room and conditioned air is distributed from the central room to the required places through extensive duct work. The central air conditioning system is generally used for the load above 25 tons of refrigeration and 2500 meter cube per minute of conditioned air. Central station air conditioning system require the following components assembled on the site: cooling and dehumidifying coils, heating coils, blower with motor, sprays for cooling, air cleaning equipments, blower with motor. Unitary air conditioning system. All the components of the unitary air conditioning system assembled in the factory itself. These assembled units are usually installed in or immediately adjacent to the zone or space to be conditioned. It is commonly preferred for 15 tons capacity or above or around 200 meter cube per minute of airflow. Recently, even 100 tons capacity units also manufactured. The classification of unitary air conditioning system. Remote air conditioning unit system. The remote air conditioning originally separated from the refrigeration, condensing unit and heating plant. Self-contained air conditioning unit. All the components including condensing and heating units are assembled in one enclosure. Unitary system for multi-storage building. This is combination of unitary and central air conditioning system. Direct air conditioning system. Direct cooling system is not a popular as distinct heating system. Very recently, the use of distinct cooling system is economically justified. Distinct cooling plants are the best suited for the concentrated load. Self-contained air conditioning unit. Self-contained units are available in wide variety of sizes and for many specific purpose. The following types are commonly available in market. Residential air conditioning unit. Air conditioning for homes is becoming increasingly popular in the Western countries. Many methods are used, each involving a different types of arrangements of the equipments. Direct expansion system. In this system, self-contained air conditioning unit is located in or next to the space to be air conditioned. Coming to the conclusion, the uniform temperature in an air conditioned room is a prime requirement of comfort and to identify the efficiency of design of the system. It is important for new building construction designers is to consider heating, ventilation and air conditioning needs within the building. It is very important to design the HVAC system based on the individual building to make sure the equipment is not oversized. There are many different HVAC systems and each tends to be unique to its building. It is adding quality to the envelope and minimizing loads can also reduce the final HVAC cost. Thank you.